we are going to discuss 12th chapter, Exponents and Powers. This is an example for exponential form. This is the 24th power of 10. Here we can read this 10 raised to 24 or 10 raised to the power 24. In this, 10 is the base and 24 is the exponent. Look at some questions. Write into exponential form 32. How do we write 32 into exponential form? Look at the answer. 32 can be written in this product of factors. This 32 has written product of prime factors. Okay, how do we find the prime factors? Take 32 and factorize it. We know already prime factorization. How many 2 in 32? 16. How many 2 in 16? 8. How many 2 in 8? 4. How many 2 in 4? 2. So how many 2's we will get from 32? 5 2's. So 32 can be written is the exponential form of 32. Now we go for the second example, 125. 125 can be written as 5 into 5 into 5, product of prime factors. So that's equal to 5 raised to 3 or 5 cube. Look at the number 100. 100 how can we write as in exponential form? It can be written as 10 into 10, right? 10 into 10 is 10 square. Or the same 100 can be written in another form, that is 5 into 2 into 5 into 2. Here all the factors are prime numbers, right? 5 2 times and 2 2 times. So 5 into 5 can be written as 5 square, 2 into 2 square. So exponential form of 100 we can write in this form also, 2 raised to 2 into 5 raised to 2. Now we will discuss laws of exponents. These exponential forms can be multiplied or we can divide also. Okay, there are some laws for that. Look at the first law. A raised to n into a raised to m is equal to a raised to n plus m. What it means? If two exponential laws have given with same base and different exponents. Look at here, same base is a raised to n into a raised to m. Here a is the same base and exponent with the same base to multiply. What to do? We just add their exponents. Okay. Second law, a raised to m by a raised to n. Here dividing two powers with the same base and different exponents. So can be done a raised to m minus n. Subtraction of exponents can be done. Look at the third law. A raised to n all raised to m. A power has taken m number of times to multiply. That is power of power. A raised to n already a power, its power mth power is taken. So how do we can find a raised to m into m? Okay. Look at these three laws. Now we explain this one, each one with examples. Look at the first one. First law, a raised to n into a raised to m is equal to a raised to n plus m. If you got this question, 2 raised to 3 into 2 raised to 5. An example. 2 raised to 3 into 2 raised to 5, both exponential forms, both the powers are with same base. So if we do this in usual method of multiplication, what we have to do? 2 raised to 3 can be written as 2 into 2 into 2 into 2 raised to 5 is 5 times multiplication of 2 by itself, right? Then after multiplying this 2 raised to 3 into 2 raised to 5 all together, how many times we will multiply? 2, 8 times, right? 8 times multiplication of 2. But this 2 raised to 8, without doing this usual multiplication, we will get just by adding the exponents, right? 2 raised to 3 into 2 raised to 5 is equal to 2 raised to 3 plus 5. This is an example. Now we discuss an example for second exponential law. A raised to m by a raised to n. Look at this, a raised to n, m by a raised to n. That's equal to a raised to m minus n. Here subtraction of exponents comes. Look at an example, 4 raised to 5 divided by 4 raised to 2. If two exponential numbers with the same base are divided, then the expression is simplified by subtracting the exponents. Look at this, 4 raised to 5 by 4 raised to 3. If you have done this by usual method, what to do? 4 raised to 5 in numerator, that we can write as 4 into 4 into 4 into 4 into 4, right? Divide by 4 into 4 into 4, 4 cube, right? Then after multiplying or cancelling 4 by 4, 4 by 4, 4 by 4 will be cancelled for 1, right? At last in numerator there remains only 4 into 4, that is 4 square. Look at the question, 4 raised to 5 by 4 raised to 3, answer is 4 square. That 4 raised to 2, that exponent 2, we will get just subtracting 5 minus 3, right? 4 raised to 5 minus 3 can be done. No need to do this usual division. That is a second law. Now we discuss an example for the third law. A raised to m all raised to m is equal to a raised to n into m. That here exponent multiplication comes. If an exponential number is raised to m is the second exponent, then this expression is simplified by multiplying the exponents. Exponents can be multiplied here. Look at an example, 3 square all raised to 4. Look this, 3 square all raised to 4, right? Here 3 square to multiply itself for 4 times. 3 square raised to 4 means what? 3 square into 3 square into 3 square into 3 square, right? Actually, how many 3's we have multiplied here? 3 square means 3 into 3, right? So how many 3's now? 3, 8 times multiplied to itself. So the last exponential form we will get 3 raised to 8. Look at this. This exponent 8 we will get just multiplying 2 into 4. So 3 square all raised to 4 is 3 raised to 8. So if just multiply the exponent, if we are doing power of a power, this is the third law of exponent. Now we will do a question for this all. Look at this, apply suitable exponential law to find. First question, 7 raised to 3 into 7 raised to 5. What is the exponential answer? 7 raised to 8, right? Because we just add 3 plus 5. 7 raised to 8 is the answer. Here next second question, 5 raised to 10 raised to 5 divided by 10 raised to 3. What to do? What is the answer? Yes, 10 raised to, here division and same base. So 10 raised to 5 minus 3. So answer is, so here power of power. So 8 raised to 2 into 3. 8 raised to 6 is the answer, right? Now we go for next point. When the negative powers comes, negative powers comes. Okay, look at this, just like this, 3 raised to minus 2. Here exponent is minus 2, a negative number. Okay, when it comes, look at these examples given. Consider the following examples of calculating the same expression. Look at the same expression, division of two powers with the same base, right? 3 square and 3 raised to 4. 3 square divided by 3 raised to 4. This is a usual method, that is 3 square is 9, 3 raised to 4 is 8, 81, because 3 into 3 into 3 into 3 into 3, right? 81. So 9 by 81 in simplest form, 1 by 9. So 9 is 3 square, so it can be written as 1 by 3 square, right? So this is the answer. 1 by 3 square is the last answer. But the same we can do this by the second law of exponent. What is the second law? Says a raised to n by a raised to m, a raised to n minus m, right? If same base and different exponent, we have to subtract the exponents. 3 raised to 2 minus 4. So here what comes? 3 raised to minus 2 is the last answer. But we have done the same expressions, but the last answers are different, right? 1 by 3 square, here 3 raised to minus 2. What you understand from this? It means 1 by 3 square. So we do some examples also. 1 raised to 4 raised to 5 is 4 raised to minus 5. X raised to minus n means 1 by x raised to n. 1 by 10 raised to 3 means 10 raised to minus 3. Okay, in this case, exponent becomes negative. Now we discuss next point. 0 exponent. So when the exponent comes as 0, look at this, 2 raised to 0 now. Look at this. When the case comes, look at these two expressions, same expression. In first case we done in usual method, 2 raised to 3 by 2 raised to 3, that 2 cube by 2 cube. 2 cube means 8, right? 8 divided by 8. What is the answer? 1. Look at this, is same number we used here. Second exponential law, 2 raised to 3 minus 3. What is the answer? 2 raised to 0. What it means? Yes, 2 raised to 0. 2 raised to 0 means 2 raised to 0 means 1. So in this way, anything raised to 0, 0 exponent rule is there. Any number raised to the 0 power, answer is 1. So x raised to 0, 1, 3 raised to 0, 1, 300 raised to 0 is equal to 1. Any number raised to 0 is equal to 1. So now we do some questions on these two concepts, negative exponent and 0 exponent. Look at this question. 2 raised to 0 into 3 raised to 0 into 5 raised to 0 also 1. So the answer is 1 into 1 into 1. Yes, look at the second question and third question, fourth question. So we will try to do this. First question, 2 raised to 0, that we have discussed, right? Yes, 1 into 1 into 1. Answer is 1. Then second question, 3 raised to 0 into 5 raised to 0 plus 4 raised to 0. So answer all becomes 1. So 1 into 1 plus 1, 2. So answer is 2. Third question, here 2 raised to minus 2 is there. So its value is 1 by 2 square. If negative exponent comes, it is equal to 1 by 2 square. So here 2 raised to 0 is 1. 1 plus 1, 2. 2 by 2 square. 2 by 2 square means 2 by 4. Answer is 1 by 2. Last question also same type. 4 raised to 0, 1. 1 into 1 plus 4 raised minus 2 means 1 by 4 square. Here 1 has cancelled. 1 plus 1 by 16 comes. Then after cross multiplication, 17 by 16 is the answer. Look at the next point of this chapter. Representing large numbers into its standard form. Okay, how do we represent large numbers into standard form? Before studying this, we have to understand some basic idea, that is powers of 10. Look at this 100. 100 can be written as 10 into 10, that is 10 square. So 100 is 10 square, then what will be 1000? 1000 is 10 cube, right? 10,000 is 10 raised to 4. 1 lakh is 10 raised to 5. Next. What it means? These all are powers of 10. Powers of 10. Look at this table. It gives everything about powers of 10. Look at the first one. 10 raised to 6. That is 10 lakh, right? 10 raised to 5 is 1 lakh. Yes, 10 raised to 4 is 10,000. 10 4 times. 10,000, 1000, 10 square, 100. 10 raised to 1 means 10 itself. 10 raised to 0. So anything raised to 0 we discussed. The value is 1. So if the exponent is negative, 10 raised to minus 1, that is 1 by 10 raised to 1, right? 1 by 10 is actually what? 0.1. 0.1 standard fractional form is 1 by 10, right? The point next one, 10 raised to minus 2 is 1 by 10 into 10, that is 1 by 100, right? 1 by 100 we already know, 100th, 0.01, 1 by 100 is the fractional form. 10 raised to minus 3, 1 by 1000, 1000th. Do you remember that? 1000th in decimal we studied, 0.001 is fractional form 1 by 1000. 10 raised to minus 4, 1 by 10,000, that is 0.0001. Likewise, this is the powers of 10. Powers of 10. If the power is positive or exponent is positive, here exponent is negative in this case. Okay. This we needed know to convert large numbers or very small numbers into its standard form. Look at this large number, that meter, 1496. Then how many zeros? Yes, 8 zeros, meter, a large number. How do we? It is not easy to read, right? In words. So better we convert into standard form. So that is the actual use of exponents. Look at this. How do we change this? We know this is a number. Our number, there is how many zeros? 8 zeros. So 1496 into this number to be multiplied, 1 and 80. Then we will get the number we know. So this number can be written as power of 10, 10 raised to 8, because there are 8 zeros. 1 for this the answer actually 1496 into 10 raised to 8 is this number. But while writing in standard form, it has a format that 1 point, always we want a number in all numbers place, then point decimal place, that way. Here 10 raised to 8, but if you put the point at 1.496 into 10 raised to 11 comes here. Why here 10 raised to 11? That I will tell you. Here 1496 can be written, if you are putting the point here at the place of 1, okay, so here 1000 comes extra. 1000 means what? 10 raised to 3. So that 10 raised to 3, that means a 3 comes extra. 3 tens comes extra here. So here already 8 tens and 3 more tens, that is 10 raised to 11, right? So 1.496 into 10 raised to 11. Look at the second example, that is speed of light. You already know 3 million meter per second is the speed of light, we know. So there are here also 8 zeros, but here one digit number only, 3 into 10 raised to 8, that can be written as 3.0 into 10 raised to 8. Now changing this exponential power of 10. So next question, here 15 and how many zeros? How many zeros? Yes, 10 zeros are there, right? Yes. So 15 into this number to multiply. This number is 10 raised to 10. But here 15 two-digit number, so we have to take the point 1.5. 1.5 to make it 15, we have to multiply one more 10 here. So here 10 raised to 10 comes as 10 raised to 11. So 1.5 into 10 raised to 11. Now we are going to discuss how to represent very small numbers into standard form. Okay, here a number is given 0.000007. This is a very small number, we know. Okay. Yes. How do we change this into standard form? Right. 10 lakh, right? Yes. 1 and 6 zeros. That is 7 by, in exponential form, 10 raised to 6. We know 1 by 10 raised to 6 is 10 raised to minus 6. We studied negative exponential law. 7 into 10 raised to minus 6 is the standard form of 0.00007. Okay. Next, one more example. 0.0016. Okay, this can be written as 16 by 10,000, right? 10,000 is 10 raised to 4. Okay, but in standard form we want a number like this. 16 can be written as 1.6. So 1.6, look at this. If you write 1.6, you have to multiply an extra 10 there. Then only it go back to 16. So here a 10 divided by 10 raised to 4. So 1 10 will be cancelled from this denominator. 10 raised to 3. It becomes 10 raised to 3. That is, at last we will get 1.6 by 10 raised to 3. So that can be written as 1.6 into 10 raised to minus 3. 1 by 10 raised to 3 means 10 raised to minus 3. Here we have an easy method. Look at this. Here we want to take this point after 7, right? 7 point. So how many numbers between numbers? 6 numbers, right? So the answer is 10 raised to minus 6. Here after the point in second question, after the decimal point, there is, here we want to get the point at after 1, before 6. So how many numbers before 6 and after the point? 3 numbers. So the answer is 10 raised to minus 3, right? Now we do these questions yourself. Very small numbers. Yes. Charge of an electron. Electron we know. Okay, a particle in atom, right? So it is very, very small. So the number you look at, the charge of electron you look at, 0 point. How many zeros are there after the point? 18 zeros, right? Then 16 coulomb. How do we write that into standard form? Look at this. How many numbers? We want to get the number up to after 1 or before 6. So before 6 and after this decimal point, how many zeros are there? Yes, how many numbers are there? 19 numbers, right? So 1.6 into 10 raised to minus 19 is the answer. Next one, that is size of a bacteria is 0.0000005 meter. Okay, then here after the decimal point, before 5, after 5, right? Yes. And including 5, how many numbers? 7 numbers. So 5.0 into 10 raised to minus. Last question, size of a plant cell. Size of plant cell 0.00001275. Yes, look at here. Here we want to get the point up to here before 2. So before 2 and after decimal point, how many numbers? 5 numbers. So 10 raised to minus 5. 1.275 into 10 raised to minus 5. Okay, right? Okay, last question. Convert into usual form. Then here we have given the standard form. You want to convert into usual form. Yes, 2.3 into 10 raised to minus 5. What to do? 10 raised to minus 5 means here we want 4 more zeros before 2. Right? So this is the answer. Look at this, 5.0 into 10 raised to minus 7. So here before 5, including 5, we need 7 zeros after the point. So look at this is the answer. The last one is standard form of large number is given, not the small number. 3.24 into 10 raised to 4. Here no negative exponent, so you have to multiply this number by 10,000. So the point comes after 4 digits. So this number is 332,400. Okay, these are the main points